boot, scooting, boogieing through this. Fill in the blanks using the available answer choices. Okay, again, valid or invalid. Let's look at it. If you leave your lights on while your car is off, then your battery will die. Your battery is dead. Conclusion, you left your lights on. Again, that's invalid. Why? Well, lots of reasons. Maybe your battery's dead because it's just old. Maybe it's dead because, I don't know, you left, I don't know, a door open. Maybe somebody unplugged. I don't know. There could be a bunch of different reasons, but this is invalid, and your battery could be dead because it was old. Oh, I'm going to get lazy. That's a lot of writing. I'm just going to put that right there. Look at that. Your battery's dead because it was old. Okay, I usually don't do that, but I decided to do it today. And then the last one, use the law of syllogism to determine a valid conclusion. So we're going to make a valid conclusion or not make a valid conclusion. The trick of syllogism is the conclusion of the first statement has to match the hypothesis of the second statement to be able to draw a valid conclusion. Let's see if that happens. If Tina has a grade point average of 3.0 or greater, she will be on honor roll. If Tina is on honor roll, look, they match, honor roll, then she will have her name in the school paper. So we can make a valid conclusion. And that valid conclusion is indeed, if Tina has a grade point average of 3.0 or greater, then she will have her name in the school paper. Which one says that? Right here, second choice, says it exactly. This one says it backwards, that's why it doesn't work. Boom! Let's go on to 13. Construction arguments. Okay, if a figure is a square, then all the sides are congruent. Figure ABCD is a square. Oops, said if it's a square. What do we know? First of all, the valid conclusion is figure ABCD has all sides congruent. So figure ABCD has all sides congruent. And how are we doing this? This is perfect law of detachment right here. It's our law of detachment. It's not a syllogism. It's not two if-then statements. It's just one if-then statement and one statement following that, which gives us this conclusion. Perfect. Bows right there. Let's go on to proofs now. We're going to do some proofs. Yeah. Given AB is congruent to CD, we want to prove that AC is congruent to BD. Okay. So AB is congruent to CD, that's given. AB equals CD, that's the definition of congruence. Okay. So then we're going to say AB plus BC equals BC plus CD. We're just adding BC to both sides, right? So that is what? That's our addition property. Look at my properties right here. Look at our front page here, guys. Look at that. We have our addition property that says I can add the same thing to both sides, right? It stays congruent. Okay, that's just the addition property of equality. And really, we could even say that's segment addition, right? All right. AB plus BC equals AC. So we're just saying AB plus BC equals AC. And then, what else are we saying? BC plus CD equals BD. BC plus CD equals BD. That's just segment addition, right? We're adding segment. So that's the segment addition property. That just says the sum of the parts, the segments, equals the whole segment. And now, since right here I have AB plus BC equals AC, I'm going to sub in AC right there. And I have BC plus CD equals BD, which BC plus CD, so I'm going to sub in BC for right here, and I get AC equals BD from substitution. And then I can say segment AC is congruent to segment BD by definition of congruence. Remember, we can work that. Anytime we say they're equal, we're going to say they're congruent. Pretty much anytime we say they're congruent, we're going to follow it by they're equal, and it's always the definition of congruence. Awesome. Given. This looks like a good one. Angle ADB and angle BDC form a linear pair. Okay, so we have two things that are going to form a line. And we're saying angle ADB is congruent to angle BDC. Ooh, they're going to say they're right angles then. I know that. That's one of our theorems. So we've got here A, D, and B, and B, D, and C, right? And we're saying, hey, they're congruent, but we want to prove that they're right angles. That's what we really want to prove, that they're right angles, which I can tell you is true. We'll get to that. So prove angle ADB and angle BDC are right angles. All right, so first we put down our givens. That's great. And then if angle ADB and angle BDC, if they're the linear pair theorem, let's find that. Linear pairs. Supplements. Vertical angle theorem. All right, this linear pair theorem they're talking about, and I would help out on a test. We're not going to see any of this, though. Is really the supplement theorem, which says if two angles form a linear pair, then they are supplementary angles. So we're just saying, hey, ADB and BDC are supplementary. Okay, and that's really the supplement theorem. Now, what does that mean? That means the measure of angle ADB plus the measure of angle BDC equals 180 degrees. And why is that? Well, that's just the definition of supplementary angles. Right? Definition of supplementary angles. And don't worry, you will have choices and drop-down boxes on your test because we'll do this digitally. So then we go from there to say, hey, we also know that the measure of angle ADB equals the measure of angle BDC. Remember, that was one of our givens, except it said it was congruent, so then we're just going to say definition of congruence. And since they're supplementary, we know the measure of angle ADB. Now check this out. Check this out. If they're equal, if that's true, we're going to take ADB right here and substitute it in for BDC. We're going to say the measure of angle ADB plus the measure of angle ADB equals 180 degrees. Sounds like a weird move, but that's substitution. And then we can actually add these together. That's the same as 2 times the measure of angle ADB, which again is substitution. We're substituting in this value by adding those together. And then we're going to use the division property of equality because we're going to divide both of these by 2, right? And in doing that, we're going to get that the measure of angle ADB equals 90 degrees, which we can then say through substitution, because we've already said ADB and DBC are equal, we're going to substitute angle DBC in for ADB and say measure of angle DBC equals 90 degrees, because congruent angles have the same measure. We can even say substitution there. I would have accepted either of those answers. And then last, we have angle ADB and angle DBC are right angles. And how do we know that? That's the definition of a right angle. They both equal 90 degrees. Definition of right angle. Awesome. That's a good little proof right there. I know this one was hard because I didn't give you choices, but I think this is good. That's why we're going through it now. We'll go through it as a class. Last, we're going to do a flow proof example. This says L is the midpoint of JK. All right, so we've got some JK. I always like to draw it. And L is the midpoint. JK intersects MK at K. Okay, so we've got some MK up here, right? If MK is congruent to JL, complete the flow proof. Okay, so they're saying MK is congruent to JL. We know L is the midpoint, which means JL is congruent to LK, and it wants us to prove that LK is congruent to MK. Okay, well, which makes sense, right? We just kind of showed that by drawing in the lines. Well, let's see what we're doing here. So, what do we have? L is the midpoint of JK, MK is congruent to JL. That's our givens. So let's write given in here. And then it goes right to, so we have segment MK is congruent to segment JL. Remember, when we say they're congruent, we're going to say they're equal right after that, and that's going to be definition of congruent segments. Congruent segments. I'm doing all sorts of shorthand to fit that in there. You'll be able to drag and drop it if it's on a test. And then once we say that, we're saying LK equals MK, but we need to get over here first because something we do here leads us to this. So let's go over here. If L is the midpoint of JK, then what do we know? We know JL is congruent to LK. Segment JL is congruent to segment LK. That's the midpoint. That's the midpoint theorem. It tells us, right? And then if we say they're congruent, we're going to say they're equal. So JL equals LK. Now, look at this. I have MK equals JL. JL equals LK. We're going to cut out that middleman and say MK equals LK. So we have MK equals LK. And if that's true, we did that through the transitive property, right? Which is right here. And that leads us to what we're proving. If we say they're equal, we can then say they're congruent. LK is congruent to MK, definition of congruent segments. Boom! That was a good team test. Prep up, guys. You're going to crush it. You're going to do better than you think. I guarantee this is going to be amazing. Write good notes. Ready, set? Peace out.